In today's video, we take a projector, a LIDAR, and a software called TouchDesigner, combine all those three, and to make this effect you see here. Okay, so let's go over the hardware we'll be using in this video. First of all is our LIDAR. This is just a very cheap, inexpensive one from Amazon. This one in this video only works with the RPLidar a1m8 in particular. You have to have this exact one, otherwise this will not work. But it's $100. Link is in the description. Comes with this little adapter board. You just connect the wires and then connect it to USB. Next, you can use any projector you want. I just have this very cheap projector for testing and messing around with. Basically, any projector works as long as you can display on it. That's all the specialty hardware you'll need. Next, let's get the driver set up for the LiDAR. So first off, we gotta get the driver for our LiDAR set up. So you'll go to this guy's GitHub page, it'll be linked in the description. Go ahead and download that zip file and put it wherever you'd like. Next, we also need to go to another GitHub repository, which is linked in this one. So we'll click on this link. And this is just a dependency to the first GitHub repository, so we'll need to download this one as well. In the meantime, I'm going to open the one we just downloaded. So we're going to download this one as a zip file as well. Open it up, extract it. And then once you have both of them open, we need to take the contents of the second zip file we downloaded, copy those, and put them inside this folder. The RPLidar SDK folder to be exact. And then we can close all this out. Okay, after that, we need to go back to the repository we just set up. We're going to navigate to the folder. We're going to right click on it, and we're going to open this with Visual Studio. Wait for that to open. Okay, I'm just going to close this what's new. Over here on the right hand side, you're going to see our folder we just opened up. So we're going to look for the C++ chop example.son. We're going to double click on that. We're going to trust the file. We're just going to click OK on this. And we should see down at the bottom some stuff pop up here. And the important thing, we should see 2 completed, 0 failed, 0 skipped. So what we got to do is we got to go back up here, right click, and rebuild solution. And that'll give us our debug folder we're looking for. And once again, we should see 2 succeeded, 0 failed, 0 skipped, which is good. Now we're going to navigate back to our repository. And inside of it, we should see this debug folder. We're going to click into that. And then here is our driver for our LiDAR we need. So we need the td Slomantic.dll. I'm going to copy that into a more convenient location for use later. Okay, we are done with Visual Studio now. Now we can open TouchDesigner. we'll go and get us a C++ chop. And for the plugin, let's go navigate to that DLL file that we saved. And we should see an angle and a distance pop up, and you see it's loaded. First thing we got to do is open Device Manager and see what COM port our LIDAR is on. So we'll open Control Panel, and we see under COM ports, there's nothing really listed there. So we go up into Other Devices, and we see this CP210x which is our LIDAR, but it's got a yellow warning symbol. So we need to go and install the um, driver for the computer itself for that. So this will also be linked in the description, but if you just go to Google, type in the name, put driver after it, and we're looking for the Silicon Labs driver in particular. Let's go to that, go to downloads. And we want the Windows drivers. One. So let that download. Extract that. All right, we'll go into that, and we'll just double click on the x64 one. We'll accept the administrator prompt, and we'll wait for the driver to install. And that's done. You may have to restart your PC for that to work. But we go back into Device Manager, and we see our Silicon Labs is showing up, and it's on COM port. Okay, once that's open, the first thing we're going to do is make sure our driver's working. So we'll go and get us a C++ chop. And for the plugin, let's go navigate to that DLL file that we saved. And we should see an angle and a distance pop up, and you see it's loaded. Go to custom and change from polar to Cartesian. That'll give us our X and Y. And now we need to go to our device manager and see what COM port our LIDAR is under. So we'll let that load, and under COM ports, now that we installed the driver, it's showing as COM4. So that's what we need to put in for the COM port. So we'll get rid of all this, and in all caps, it's just COM and 4, or yours might be COM 3, 4, 5, whatever. After that, we'll hit the activate switch. It might lag for a second, but then we should see some data coming through. This is our data from our LIDAR. Next, we'll go ahead and put that into a null. And then we'll do an add stop into a convert. And we'll take the output of that convert, hit tab, when you're dragging the output of it, and we'll put down a geometry node. And that way those are attached. So next we need a material, so we'll go grab a point sprite and drag that onto our geometry node and put it as a material. Next we need a camera. And finally a render. And now you should see all those connect. So let's go back over here to our convert and change the convert to particles per point. And then in our geo, we go to instance, internal instancing, and drag our null in here to the translate op and do X and Y for translate X and Y. Now we'll go over to our add stop and turn on add points. And now you should see some data coming in from our LIDAR. So now we need to go to our camera, we click the plus button, right click, click home all, and that'll center everything for us so we can turn our point sprite constant point scale up to make our LiDAR data more visible. So we're going to go ahead and do that so it's easier for us to see. And now we can see in our render, now we see some data coming out. So we got our data. Now we need to do some converting and filtering of our LiDAR data to get our desired end result. Now off of our render, we will go and grab a null, put that down there. And over on the section on the left-hand side, under mapping, we're going to look for Cantan mapper. We're going to drag that in. That's going to allow us to map our picture to the wall from the projector. So we'll drag that in. Might lag a little bit. All right, that's in. Great. So let's click on this, and under Cantan, we're going to click Open Cantan window, select the square, draw a square. And now we're just going to drag the null we just made into this square, and as you can see, the data is being put on there. The Cantan mapper, to move around, it's a little bit weird. Middle mouse button, hold that down, move left and right, that zooms you in and out. Right click will pan around. So we're going to take this and we're going to drag these 4 dots over these 4 corners of this pink square. And if you notice on the left hand side under the tools, I have clicked the arrow that's not filled in, and that gives us these points. All right, that's good for now. So we'll get out of that. So now let's give a background to our data so we can see our data a little bit more and we can see the edges of our screen. And to do that, I'm just going to go grab a rectangle. Scale it up a bit and change the color to whatever I want. I'm going to use red in this case. Then we're going to grab a null coming out of the Cantan mapper into an over, which is going to allow us to put our data on top of our background. And then we'll follow the over up with a window that'll allow us to display the output on whatever screen we have connected. On that, we're going to turn borders off and then change it to whatever monitor output we want it to. But as you can see, our image is distorted. So we got to go back up here to our rectangle, go to common, and for the resolution, we got to put 1280 by 720. And as you've seen, that fixed our aspect ratio being off. And if I click middle mouse, click the over, we can see it is the correct resolution. So now I'm going to go ahead and open this on my other screen. So now we see this on the projector. Now we gotta start mapping this to our stick we have here. And to do that, we're going to go back to our Cantan mapper, open the window again, and we're going to use our points here to do that. So first, I'm going to go to the solid filled in arrow under the tools, and this will allow me to tilt it. So now it's straight the way it should be. So let's move this over, and we need to add a few things here. The first thing we need to add is a transform and a flip. Because if you notice, our data on our wall, it's all inverted, so we need to invert it. And we can use a flip to do that. So we'll grab our flip and flip it on the X and the Y axis. Okay, going back to our Can10 window here, we can use these points to kind of calibrate and map where the points on the projector should be in relationship to the stick we have. And so we'll just go around one point at a time, just dragging these. It's kind of a thing. You just kind of have to fill it out and get used to doing it. And we'll do that. And it's easy if you got a helper to help you do this. You can do it without it. It's just kind of a pain. So we got those two corners. So moving to the left side. And then now the top left. Okay, great. All of that's mapped now to where it needs to be. As you can see now, the dot follows the stick. So now we don't want just a dot. We want to attach an object to this dot. And how we're going to do that is first let's turn our particle scale up by going to our point sprite and turning the constant point scale up. We're going to turn this up quite a bit to 20. And you can play with this and adjust it to how your needs and stuff. And so now we see we got this kind of square on our screen here. So now we need some way to get the X and Y position of our little square here. So what we're going to do is coming off this null, we need to put down, first of all, a blur. And this will take the multiple squares we have and kind of, make it look like one object. So we'll grab that, and then we need to put the output of that into a blob track. And for a blob track to work, let's mess with the blur a little bit. You just fiddle with this, and get yours to work just however you'd like. There's no real way you have to do it. You just have to kind of play with it a little bit. And so we'll turn the pre-shrink up, and we can see, okay, it's more or less a single dot now. So out of our blob track, it has a dat node attached to the bottom of it here on the right. And you'll see in here we have our U and V coordinates, which is basically your X and Y. So let's go get our object to attach it to. I'm just going to use a circle here for convenience. Let's turn the size of our circle down a little bit. It's not so big. Okay, so now we need a way to attach our U and V coordinates to our X and Y position of our circle here. And one way we can do that is if I just open a terminal here. I'm going to go ahead and paste this expression, this Python expression in here that we're going to use. I'm going to explain this real quick. Basically, what this is saying is first we have this op, which stands for operator, and that's saying, hey, which node do we want to target? In this case, we want to target the blob track 1 underscore blobs node. And in that node, there's a table. So what, column and row of the table do we want? Well, we want 1, 2, which will give us the U coordinate. And so that'll give us our raw data coming from our blob track. But we gotta add this or 0 into here, because when blob track isn't detecting anything, it's going to return a null value instead of a number, and then that's going to make our circle freak out because it's getting a null value instead of a number. So we got to put or 0, so that way when there's no data coming from the blob track, our circle still has a place to go. And then we don't want our circle to be visible on the screen when we're not touching it, so we're going to add a minus 0.5, that way it's off of the screen. So I'm just going to go ahead and copy and paste these values into my X and Y, and these will also be linked down in the description for you guys to copy. And as you can see, now that we got it pasted in the X, our circle is moving in the X-axis. And now if we put the Y1 in there, it'll move in the X and the Y-axis. Okay, there we go. Now our circle is attached. And you'll notice our circle, its aspect ratio is wrong. So we're going to go to common again, change its custom resolution, and put in our 1280 by 720, and that'll fix that problem. There we go. Get rid of this point sprite I accidentally put here. Okay, so now let's change the output to our circle instead of our data we did have. And let's go ahead and turn the size of this circle down a little bit more. And now we can see our circle is attached to the stick. So we've now turned a wall into a touchscreen, and you can do all kinds of effects and put buttons on it, and the sky's the limit with this.